This is 5.1 exponential functions. You covered this in a prior class, and notice that an exponential function, notice the exponent is the variable x. And so that is what varies. The exponent varies. So here's some examples, like if I have 2 to the x power, but x equals pi. So basically 2 to the pi power. Well, the same thing here, 0.6 to the x power, but x equals square root of 2. So 0.6 to the square root of 2. And that's just a matter of plugging those functions in. So 2 raised to the pi power. You know, you get your, and then, by the way, I may tell you to round it to 3 decimal places, 4 decimal places, whatever, you know, whatever the instructions are. But basically, you're going to just use the calculator to evaluate it, and that's what you would get to first evaluate those type of problems. And then notice if I ask you to graph it. Now, remember, graphing is basically, think of an XY chart. It's just a bunch of evaluating problems. So 2 to the 0 power. Let me write 0 because that means 2 to the 0. If I write 1, that's 2 to the 1. If I write 2, 2 to the second. So you don't need to grab your calculator on a lot of these problems because you can simply evaluate them because some of them are quite easy to do. Even -1, so 2 to the -1, 2 to the -2. So all of these can be done quite easy. Anything to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. Even if I did 3, you know, 2 to the third power is 8. -1, remember negative exponent means to flip it, so I'm going to flip the 2. Here I'm going to square it and flip it, so that's 1/4. So if again, you don't need a calculator for this, but again, if you wanted to plug it into your calculator and get it, your calculator would come up with probably decimal answers on those, but either way, it's fine. If you graph this, you're going to have, let's see, 0, 1, 1, 2, 2, 4, 3, 8. Notice it's not linear. This is an exponential. Notice the title is called exponential, so things that grow exponentially. So -1, 1/2, -2, -1/4. And I want you to notice, let me go and plug this to your calculator because I want you to notice something. So 2 to the x power. Now notice the table. So notice as I get more negative, because this looks like it's going to, like do something like this, like that. Okay? But I want you to notice at -4, it's still above the line. It's still positive. It's very tiny, but it's still positive. At -5, -6, -7, -8, -9, -10, -11, -12, those are all positive numbers. So this really, and then it exponentially goes up. So even 2 to the 4th would be 16, and then it's just going to keep going up. So this is going to come like really far down like this. And this is going to get really, really close to that line, but never actually touch it. Okay, it's going to keep going higher or lower and lower and lower. So it starts off like really low up to that line, but it will never hit that, which means there is a horizontal asymptote at y=0. It will never hit 0. So even if you kept going higher and higher and higher and higher and higher, those are all positive numbers. Now, by the way, if you kept scrolling higher and higher, eventually your calculator will say 0, and you're like, Dr. Murphy, you know, it does hit 0. Well, the calculator eventually kind of gives up in a sense. It just gets really, really tiny, so tiny that the calculator says, it's close to 0. Then the calculator just says it is 0, but it does not. It actually always will be above the 0 line. So whatever number you plug in, like 100, you know, this is just going to be 2 to the or -100. So 2 to the -100, and you know your calculator may say, hey, that's 0, but it's not. Okay, it's actually going to be above 0. It's going to be a positive value. All right, because that's just 1/2 to the 100, and that's a really, really tiny number. So again, there's an asymptote involved here. It keeps going exponentially higher up, exponentially really, really low. And so think of things that are exponential, that grows quick, like bacteria, population. You know, sometimes money grows exponentially. So it's not linear, but it's exponential. So it grows linearly exponentially. Notice the base here is 3, and then it's raised to the negative x power. Again, you can make an xy chart and start plugging in numbers. So even plug in 0, 3 to the 0, but the negative 0, plug in 1, 2, 3, I mean, whatever you plug it in. So even 3 to the 3rd power, but it's a negative, so that's going to be 1 over 27. Okay, so you can plug in -1, -2, -3. You can plug in any of those numbers and do most of the calculations in your head without using a calculator. But there is something I want you to see here. So 3 raised to the negative x power. So again, if you notice the graph, okay, notice this right here. We have the last function started off really, really tiny. Remember, we always read the graph left to right. So this one starts off tiny, and then it gets exponentially, it grows. So this is a growth function because it grows from left to right. We always read the graphs from left to right. It grows. So this one right here, if you notice, it starts off really, really big, and then it's going to get really, really tiny. And again, if you look at the graph, it looks like it hits that 0 line. That's why I want you to look at the table. So if I look at the table at, let's start at 0 real quick. So at 1, it's really tiny at 1. It's at 0.3. If I just round it. So at 1, it's at 0.3. At 2, it's at 0.1. So it's getting really, really small. So even at 3, it's 0.037. So it's so close to that line. That's why when we look at the graph, it looks like it's hitting the line, but it's really not. It's still going to be above it, even if we went to 10, even 100, it's still going to be above that line. So again, we have an asymptote right here, y equals 0, and then when you start graphing this right here, I didn't look at the other values, but you have the negative values, -1, -2. So -1, you're going to get 3, and this is 9. So -1 is 3, and 9. So again, it starts off, again, reading left to right. So it starts off really big, and then it's going to get exponentially lower. Again, don't cross that line. It doesn't hook back up. It keeps getting smaller and smaller and smaller. So this is a decay function. Again, something that decays gets smaller and smaller and smaller, compared to growth, starts off small and then gets big. So a growth and a decay function. So if I had, by the way, if the base is bigger than 1, like this is a base, so if it's bigger than 1, then it's growing. Okay? Now this base, you're saying, well, this is bigger than 1. Well, remember a negative exponent really flips it. It really flips it. So that's why this right here is really 1 over 3 to the x power, or 1/3 to the x power. So that right there tells me that anytime it's less than 1, in between 0 and 1, anywhere in between 0 and 1, it's a decay function. So again, a growth function starts off small, goes big, and that's if the base is bigger than 1, then it's a growth function. And if the base is between 0 and 1, it's a decay function. Okay, it's a decay function. So let's look at this right here. Now, you're like, what? I have to graph all of these functions? Well, we already graphed 2 to the x power. Okay, so I want you to, let me go back to that function, 2 to the x power. And that's what the function looked like. Okay, now this is the parent function. And I want you to notice each of these functions and how does it, without using our calculator, we can use our calculator for all this, but without using a calculator, we talked about transformations earlier. And so what does this +1, notice the +1 is up in the exponent area, what would that +1 do to it? So again, we talked about it earlier on an earlier lesson, and then notice the +1 is over on the outside. So I want you to notice each one of those. So let's look at, let's look at 2 to the, oh, I already have that punched in, 2 to the x. And then just look at the 2, I'm going to raise that. Notice where the +1 is, it's in the exponent. And then if you just notice this, what did that do to it? Okay, so that, it looks like it raised it 1. Okay, it looks like it raised it 1, but it didn't. you have to actually notice the tables. So if you notice the tables, what's actually taking place on each one of these, so notice the table. If you look at and graph each one of these, if you actually look at the graphs of each one of these, like plot the points, you'll see, and if you remember what we talked about this earlier, this number over here is actually taking it to the left or to the right, not up one, not down one. It's actually taking it to the left. It's always the opposite. So it's actually taking it to the left one space. So again, you can see that if you look at the table and then also at the graph itself. Now the number on the outside is taking it up or down. In this case, it's up one. Notice that. Matter of fact, let me jump down to here. So notice this is still 2 to the x power. So this is the parent function. But notice this right here is taking it 3 to the left and 4 down. Let me go ahead and plug that in just so you can see it. So x plus 3, then minus 4. So, by the way, I automatically know the other function before I push graph. So the other function looks something like this, okay? And this one is actually going to be shifted 3 to the left. So each of these spaces will be shifted 3 to the left and then 4 down. So I know this is going to be shifted 3 to the left and 4 down, and so you can literally take each one of those points and shift them in those directions. So you can see each one of those points is being shifted 3 to the left and 4 down. Okay, so the same thing with each one of these. The number in the exponent is taking it to the left or to the right, the opposite, and the number on the outside is taking it up or down. And again, what we've already talked about here, the negative, what it does to each one of these. So the negative here, because it's in the exponent, it's actually going to change it from a growth function, because this is a growth function. But that negative exponent is actually going to make this a decay function. Okay, so that's literally going to take it to the decay. Again, if I plug that in, so 2 to the negative x power. Just look at that one. See, the black graph it's decaying. And then if I look at the last one, so that negative in the front, notice exactly what that's going to do. It's still a growth function, but notice it actually it like flipped it about the x line. So it literally made it go down here. So each one of these points got flipped down here, got flipped down here, got flipped, got flipped, got flipped on the x-axis. So again, we talked about those transformations as well. So you're going to have graphs just very similar to this. It's going to transform them, and you just have to describe each one of those, how it's being transformed. I also want you to notice, the point where it crosses the y line, the y-intercept. It does not have a the very beginning. This one, remember, the y equals 0 was the asymptote. This one right here, because it was up 1, now the asymptote would be y equals 1. It will never hit 1. Like this right here, the y asymptote is -4. It will never hit -4. If you go back and look at that function, it will never hit -4. It gets very close to -4, but it never hits -4 to be able to do that. So, matter of fact, you can go back and look at the table. Again, this may be confusing. This was the third one, the black one that we did. I should have color coordinated this to be able to do this, but so this one's the red one. Okay, the red one. So if you look at this one, each one of these, you can see where it's going to hit. So at -3, -5, -6. Notice the red column is never going to hit -4. It's never going to hit that. So again, that's graphing exponential growth functions, exponential decay functions, but these are all exponential functions. And this is just part 1. Make sure you watch part 2.